Hello, everyone, and welcome back to the Winter Data Meetup. I hope you all enjoyed the insightful talks and discussions we had so far. Meet Alexandra Zenchenko, a lead software engineer at EPAM. Alexandra explains how our digital actions affect the environment, and especially in big data, and she will also share practical tips and smart strategies for making data more eco-friendly. Now, before we dive in our next session, I'd like to take a moment to ask for your support in helping us grow our community and recognize the speakers. Firstly, if you enjoy the content we've provided and want to stay updated on future events and talks, please consider hitting the like and subscribe buttons below the video. Now, for something a bit special, in the video description below, you will find a link to the talk page where you can provide feedbacks on this talk, give speaker a badge, and rate the session. Your feedback is incredibly valuable to us as it helps us improve future events and also provides recognitions for our speakers' hard work and dedication. Throughout the talk, if you have any burning questions or insights you'd like to share, don't hesitate to type them into the chat box. Our team will be monitoring the chat closely and we will collect all your questions to discuss with the speaker after the presentation. And now, let's welcome our speaker to share her valuable knowledge with us. Alexandra, the stage is yours.
Thanks a lot. So I will switch the slide. Let me introduce myself. My name is Alexandra. Currently, I'm working as a lead software engineer at EPAM Systems. I work in data practice Poland. Before I had some academic career. I have PhD in mathematics, and for almost 15 years, I've been working in data, building different quite complex solutions, including data visualization, integration, machine learning components. And currently, I'm working as a data architect, designing enterprise data models. Regarding my interest in ecology, it comes from my family. My father is an environmental scientist, but well, this topic maybe was not so interesting for me before. I read one article where I knew that one Bitcoin transaction, not the mining process, uh, consumes the whole swimming pool of water, which impressed me so much that I decided to understand if it's the same with our usual data integration activities, because I know how huge amounts of volume we usually pull during the day. But first, let me give a short introduction into the topic. I will explain what is a greenhouse effect and what is a carbon footprint. So there are gases which are called greenhouse gases. There are four of them, four categories: carbon dioxide, methane, nitrous oxide, and a set of gases called chlorofluorocarbons. What they do with our environment. Energy from the sun normally reaches the Earth's surface mainly as light, but then it's reflected already as a heat. And it should leave our atmosphere, but it doesn't, because these greenhouse gases, they stay in the atmosphere and they reflect this infrared radiation back to the Earth, warming it and also warming the atmosphere. This is called the greenhouse effect. And the CO2 is considered to be central in global warming for the following reasons. First of all, we're adding 35 billion tons of CO2 every year and even increasing this volume, mostly by burning different kinds of fuel, such as coal, oil, and maybe something similar. And it doesn't go away. Because it stays, and the statistics says that 60% of CO2 leaves the atmosphere within 200 years, and the rest of it stays for thousands of years. So it means that everything what we emit today will stay with us for hundreds of years, and this way warming and warming our planet. And also a lot of industries, such as, for example, steel production, really depend on carbon-rich fuels. And our economy cannot be restructured so fast to get rid of these processes. And also CO2 is taken as a standard. All the other kinds of emissions are measured in CO2 equivalent. A little bit of information about other greenhouse gases. In fact, water vapor, which is clouds, it's also a greenhouse gas, but it doesn't harm. It leaves atmosphere in 2 weeks. It doesn't normally also have any harmful substances inside. Yeah, and then it turns into snow or rain. Methane. It is even more harmful than CO2, but it stays in the atmosphere for approximately 10 years. These emissions come mainly from cattle. So we're breeding cows, and they produced methane usually. And also there are leaks from gas wells and pipes, which also add to its quantity. The next category is nitrous oxide. It lasts for over 100 years in the atmosphere, and it's almost 300 worse than CO2. Mainly it goes from fertilizers, from agriculture. And the worst is the set of fluorinated gases. They're used in refrigeration, cooling systems, and we see that they, first of all, thousands of times worse than CO2 in their warming effect, and they also stay in the atmosphere for even thousands of years. So the impact of increased amount of these gases in the atmosphere is getting worse and worse. Since industrial revolution, we emitted more than 2,000 gigatons of carbon, and we're in track on triple this amount by the end of this century. If we're not going to stop producing CO2, then quite soon our temperature compared to pre-industrial time will raise more than 2.5 degrees. And scientists found that then it might cause really irreversible changes, such as sea level rise, because ice will melt. Our atmosphere will become very warm. Humidity will rise, but not everywhere. Some regions will become very dry because of heat. Some of them will become very humid. Rain maybe will fall rarer, but the storms will become really destructive, and we already may observe this effect. Also, oceans will become more acid, and a lot of organisms which currently live there will just die, especially those who build shells. And all of that will affect our food supply and water supply, because drinking water will become salty because of the levels of the ocean, and because of this dry air, we will not be able to grow some kind of crops, for example. So we see that the impact is huge. And on these two graphs, you may notice the correlation between CO2 emitted and the warmth of the atmosphere. So we see that the temperature is already 1 degree above the level which it was before industrial revolution. There was a conference in Paris in 2015 where the so-called Paris Agreement was taken, where countries agreed between themselves that they will take as many efforts as possible to keep global warming within the range of 1.5 degrees centigrade. Because then, as I said, the effects may become irreversible. And there is the notion of so-called carbon budget. This is the amount of CO2 which we still may emit before we reach this level. There is a CO2 budget clock. This link is clickable. Then you will be able to check. So these screenshots were taken 2 days ago. And we see that we have only 5.5 years until we reach this level of 1.5 degrees centigrade. And after it, we will already violate this Paris Agreement. And like more soft scenario is to reach 2 degrees. It will be in 23 years with current state of things. What can we do? Because we keep emitting, these gases stay in the atmosphere. What can be done here? First of all, there is a strategy of reducing emissions. The second is to try to change something in the atmosphere, to do so-called climate engineering. And the third strategy is adaptation. Which measures can be done to reduce emissions? First, to use renewable energy, solar, wind power. Also, scientists say that nuclear fission is even better than burning coal and oil. Also, we need to increase efficiency of transport and buildings. Try to capture as much of greenhouse gas components as possible directly on the pipes, for example, of the plants and factories. Also, there are ways to remove carbon from the atmosphere. For example, by use of sea plants, trees that may consume CO2. And the most important is taking governmental actions, applying taxes on on the industries which use coal and oil for their production, and subsidizing carbon-free energy. This is currently already done. Yeah, and this slide is just to show how trees may really help us to offset our carbon emissions. To consume 1 ton of CO2, so on average, 38 trees are needed. But this should be already grown up trees, but not all, because all trees don't consume CO2. So it's also quite complex. Not every tree, it also depends on the tree, which tree consumes, which doesn't. So it's not the only action that we should take, planting trees, but of course it helps. So the second strategy, climate engineering. Here there is an offer to spray sulfur in the atmosphere, which will just reflect sun. So sun will not heat up our planet, will not get sunlight because our atmosphere will become a mirror. Of course, it's quite dangerous, and second, it will not help to remove CO2 and other gases from the atmosphere. It will just add sulfur. But for example, it will not help to remove acid from the ocean, which is the result of presence of CO2. That's why this is an option which is currently being investigated, and already scientists are thinking how it can be developed, but it will be kept in the pocket for the situation where nothing else can be done. So it's not the best. And the third option is adaptation, which is actually doing nothing, just waiting what happens, hoping that it will not be so bad as scientists predict. And then most nations will have to deal with the consequences. Some will suffer more, some will suffer less. Those who live close to the oceans will have to build seawalls uh, to defend themselves from floods. Those who live closer to some hot areas probably will have to move away because it will be unbearable living there. Yeah, then what is a carbon footprint? Carbon footprint is the amount of CO2 and its equivalents which we produce during our activities. On average, for a person in the United States, it's 16 tons per year. For on average, on the Earth, it's closer to 4 tons, but to achieve goals of Paris Agreement, we need to drop it to under 2 tons by 2050. Which steps can be taken here? We need to change our mindset by thinking about the consequences of our consumption patterns, reduce our energy usage, for example, to low down the heat in our apartments. Also use alternative transportation, for example, bicycles or at least public transport, and to eat less meat because cows which we breed produce a lot of methane. And now let's switch to the topic closer to data. Digital carbon footprint is the result of our daily digital activities. Usually, when we send an email, we don't think about any amount of CO2 which it can produce, right? But still, every email produces some share of gram of CO2. And in general, internet and our stored data, they are supported mainly by data centers or stored on premises, and they account for 2% of global electricity demand. And it's predicted with current development of these technologies that by 2040 it will raise up to 14% of total emissions. If we to data centers and infrastructure for data transition, and we will add our devices and supporting systems, then this will account for almost 4% of all greenhouse emissions. And it's expected to double by 2025, even with measures already taken by data centers for a reduction of emissions. So first of all, what can we do personally as people, not as, for example, data engineers? We may reduce our e-waste. It means different advertising emails that we get. We can just unsubscribe. It's better to power down our devices, to just switch off everything that is not being used for more than 2 hours. Clean our cloud space, remove all old photos, this multiple duplicates of selfies. Also clean our mailbox after receiving emails. For example, at the end of the day, limited unnecessary streaming. For example, if we're watching a movie on Netflix and going to sleep, it's better to switch it off. Also, send emails more mindfully. Maybe stop sending thank you emails. Yeah, and the maybe least achievable, at least for me, Perils renewables. So this picture shows global trends in internet traffic, which is the light blue line. So we see that it's just growing almost exponentially. Then data center workloads, it's up to 2020. I think that in the last 2 years, this line will become more vertical as well. And the green one is data center energy use. So we see that they really taken measures here, and it helps. Uh, then let's talk about data centers. What causes emissions of data centers? First of all, electricity consumption. And the most interesting that this energy consumption is spent not only to run the servers, but also to cool them down. Also, water consumption. I've read about a data center in Arizona which called water lack of water of in the local houses. People started to complain so much water it consumed. And also we understand that if every data center is just a huge not storage but kind of storage of CPUs which need to be replaced maybe every 2-3 years, and they also contain a lot of harmful substances affecting our environment. Yeah, and in this picture you may see the number of data centers which is constantly growing. And data centers, all of them are different. The so-called hyperscalers, AWS, GCP, Azure, they really take a lot of actions to reduce their emissions and to lower the carbon footprint of their centers. There are other data centers of other companies which are more harmful. But even if we consider, for example, AWS, we see that they really differ in amount of their emissions. Why? Because, for example, we see that the one which is in Sweden, it emits the least amount of emissions because it's cold. It doesn't need to spend a lot of energy for cooling. And expectedly, the center in South Africa is the most harmful because a lot of energy should be spent on cooling, and I assume that also a lot of water, and there is also already lack of water in Africa. Same for GCP. And yeah, Azure has less data centers, but the same situation. The one in London, Cardiff, they're much better than the ones in hot areas. So when we're selecting a data center where we're going to place our data, we may consider it and think about the harm which will make by placing our data, for example, in Indonesia. Well, now we all know that it's a boom of AI. Every month we get some news about release of a new, for example, language model. And we should also think of how much resources are spent on training these models. So yeah, it's written here that the share of AI market is growing, and it is expected to grow even more. The general trend in AI is using more and more complex models where we need to train millions of hyperparameters, which of course requires a lot of resources. This picture is given by OpenAI, and interesting that they show the complexity of their models in so-called petaflops days, not in kilowatt hours, for example, or not in CO2 emissions, and I couldn't find the correlation between petaflops and kilowatts. Petaflop is one operation done with float point number. But yeah, we can see that it's growing, it's getting worse, so emissions will also grow. One more factor is dark data is single-use digital data. I guess that everyone knows how much of data we store and we add every day by keeping emails, making videos, and just storing them somewhere in iCloud. And companies also produce this kind of data, but just loading it just in case. So it the estimation is that companies produce 1,030,000,000 gigabytes of dark data a day. This is the same as 3 million flights from London to New York. Yeah, and I forgot to mention that currently the impact of data centers, cloud, and all infrastructure connected to it is comparable to air industry, airlines. Uh, yeah, and how can we deal with this dark data? And here, what helps is the most boring topic ever, which is data governance. So if somebody doesn't know what is that, it's a set of structures, principles that ensure that data is gathered, stored, processed, and disposed efficiently and securely. Uh, um, if the company follows the principles of data governance, then each data point is categorized, secured, and has its place in the organization. So no uncontrolled data may reach the servers of such organizations. It improves the processes within the organizations, helps, for example, that data scientists find the information quicker and also use it more efficiently. It reduces security risks because each data element is secured. And how it may help also to reduce our carbon footprint. Uh, as far as data is classified, prioritized, redundant data is removed, trivial data is not added to the databases. All retention policies are set up. Everything which is old and may be archived is archived. It helps to reduce data storage. Helps also to reduce unnecessary data operations because data is already cleaned before it gets to servers. Access controls are implemented so users have really limited access to the data and cannot just operate it uncontrollably. And also, data governance may help to leverage data for sustainability, for example, by tracking and monitoring energy consumption, and also by optimizing resource allocation. So here, before we talked about data storage, now we can talk about data processing. Green computing is a environmentally conscious design, manufacturing, use, and disposal of computers and all the related technologies. Its benefits for the companies if they decide to go this way to select green computing. It first reduces CO2 emissions. It boosts companies' reputations. Later, I will explain why. And it prepares companies for future environmental regulations. There is already founded organization named Green Software Foundation. As far as I know, EPAM is also a part of it, which has the following principles. Energy efficiency, we need to consume the least amount of energy possible. Hardware efficiency, it's not allowed to exchange, for example, laptops within organization too frequently. And carbon awareness. So the users, the employees of these organizations use electricity mindfully. Examples of green computing. For example, Updating the architecture. Changing a monolithic architectural approach to serverless, which reduces carbon footprint. Uh, Using cloud storage instead of storage on premises, because cloud companies such as Google, Amazon, Microsoft, they take a lot of efforts to help their customers reduce carbon footprint by storing the data on their servers. Also, we may consider storing data locally, sometimes on our devices, or at least closer to the place where we are, by avoiding hops of data between different clouds, for example. Using of virtual machines. Virtualization really helps, because in this case, we may use single computer for multiple environments, which also reduces energy consumption. Analyzing and improving application performance, removing outdated old applications which didn't use green computing principles, by replacing them with something, for example, cloud-based. Applying edge computing, where when we keep our data closer to a data source, for example, keeping data for users from England in some cloud based in England. Raising algorithmic efficiency, so improving of performance of the algorithms, for example, using hashing, index search, etc. And taking care of resource allocation, where we mindfully select the server where we will keep and process our data, routing the data to data centers with a smaller amount of emissions, for example, in some cooler regions. And now sustainability is becoming one of non-functional requirements, because it influences software development, and also preferences of the customers, who are already becoming aware of the carbon footprint which our software may leave. What may help to make data architectures more sustainable? First of all, we may think about how the components of our architectures communicate between each other, and we should focus on the ways to limit the amount of data requests and of the volume of data requests. So, for example, not to put everything what we have in a record, but only the most essential attributes, or try to combine multiple requests into one request, in order not to raise their frequency. Computation, limited multiple abstraction levels, also apply caching, by also communicating to the customers, trying to find some trade-offs in the latency of the data. Also, it's better to, I already talked about it, to apply data cleaning before it reaches the servers, in order to avoid this cleaning on the fly. Also, mindful choice of languages and design. Unfortunately, Python, which is now the most popular language for AI, is the language which operations produce most of CO2. Choice of AI models, also it's obvious. Improving user experience, also in terms of sustainability, trying to find some trade-offs in latency, reliability, probably availability, load times. Maybe a report will load a little bit slower, maybe not, it will take not 1 second, but 2 seconds. But we will, our solution will be more sustainable. Data storage, here the recommendation is to consider applying more structures on the data, to build data models more mindfully, to avoid usage of data lakes when possible. If we may structure the data, better to do it, because otherwise the data will become just the dark data. Nobody will ever work with that. Also, to think about the deployment environment by selecting the data centers, for example, and also time of deployment. It depends when we work, when we do high load uh, workloads, because also it's quite obvious that, for example, at night it's cooler, so CO2 emissions will be lower. And carbon aware testing, where we don't run tests to check every single issue, but for example, fix several issues and then run the test. Here, this slide actually was added just for correlation of the content with the topic of this presentation. So here there are two examples of SQL queries. One of them is with low carbon footprint and another one with high carbon footprint. So in one of them, the volume of data is restricted to 1 month. Another one uses 1 year of the data. And also select asterisk is used when we get all the records from the table instead of just picking up those which we really need. But of course, it's not only the code, which is essential here, but also it depends on database size, on server efficiency, and the usage of network. And to conclude, I would also like to mention ESG regulations, which now start acting in Europe and already also in other countries. ESG goes for environmental, social, and governance. Uh, this is a part of corporate sustainability reporting directive, which which will make all the companies to report on these three directions by January the 1st, 2024. In Europe, the rules started acting this year on January the 1st, where companies, as far as I remember, stock listed companies need to report their emissions, their uh, structure of the company, some security points of the company, and how they protect human rights. For example, the proportion of women in the companies. But environmental part, that is CO2 emissions, is the most important here. And this reports should contain three scopes of KPIs: scope 1, 2, and 3. Scope 1 are direct emissions of the company, mostly from transportation and, for example, fuel type, which they use to produce steel, for example. The second is indirect emissions from purchased electricity, and the third is value chain emissions. So if we take a digital company, then it will have to report in scope 3 the usage of the power of data centers. And this causes such a big interest to sustainability of software solutions. Some companies already started reporting, and we see that, for example, Samsung is the worst here. They really produce a lot of CO2. And of course, their goal will be to reduce it. Gartner research predict that Google, AWS, and Microsoft now will focus on reducing their emissions in order to influence purchase decisions, because starting from now, taking into account ESG regulations, the companies which use clouds, and now every company uses software, uh, they will turn more attention to sustainability. And of course, they will try to select that cloud which will allow them to report less emissions. So now that's why these hyperscalers already started working on that. And they already set quite challenging goals for themselves. So Google is working towards 24/7 clean power by using, for example, wind power. You may find photos of Google Cloud data centers surrounded by the windmills. Amazon is also shooting for 100% renewables by 2025. Microsoft is moving on the way of transparent reporting of the emissions for their customers. And also, it's not included here, but you may find on the web pages of Google, Microsoft, and AWS um, the pages which allow to calculate the carbon emissions from your solutions if you use these clouds. So to conclude, uh, the humanity is already taking a lot of efforts in this direction, and we also need to be aware of it and take actions from our side. Thank you very much. I used a lot of resources, tried to also list all of them here. Lizaveta, you're muted.
I'm sorry. So thank you for the presentation, Alexandra. And now let's move to the questions. And the first question is, we see numbers of CO2 produced because of data centers, but can it be compared with cars and trucks?
Yeah, as I said, it can be compared to aviation industry, which is considered to be the largest emitter before, one of the largest. So we're comparable to aviation. Trucks and cars produce less.
Okay, thank you. The next question. Will it help if number of queries per second is limited? For example, denied to ask Google too frequently, or instead of sending an improper query, think first.
Of course, it will help.
Okay.
So
Um,
the less data we query, the better.
yeah.
So it's better to think first and then to create a query instead of also sending requests frequently.
Okay. The next question. I know that cloud services are moving to 100% renewable energy. Is it a good path in your opinion?
Yes, it's good path because we don't emit then. But also, I had to shrink my presentation. But at the very beginning, there was a slide which explained why we cannot go 100% renewable, because the sun doesn't shine always. So solar panels can be used 100%, right? The wind also doesn't blow all the time. And usually, if there is sun, then there is no wind, and vice versa, right? So,
Mhm.
by estimations, so now only 10% of energy is replaced by renewables in the places where efforts are taken, and this amount cannot be higher than 30-40%. Just not possible.
Okay, got it. So the next question is a little bit tricky, I guess. Is it more eco-friendly to store non-archived data or store archived data and use more compute resource to unarchive it?
Depends. It's tricky.
Okay.
It
So,
depends on how often you need to de-archive, I
okay.
guess.
So, does it mean that will it help if we use cold data storage classes, for example?
Mm-hmm. Yes, that's why they're
Okay.
called.
Okay. The next question. Now we work from home, travel to offices less. What else can we do to support our environment?
Mm-hmm. Yes, so actually, when we started sitting at home, when COVID started, right? And that was the time when internet started to grow so rapidly.
Hmm.
So from one side, we reduced our emissions by using cars, but from the other side, we started spending more time online. And also also you may find, I just don't remember the numbers, but when we are streaming something, right? Just some not very intelligent video which nobody will see, which will appear somewhere on the internet. It also causes emissions. So before people were driving, right? But now people are doing some other activities which
Okay.
affect the
Yeah, I
environment.
agree. Okay, and more questions like more daily life related. What about moving to other countries? For example, traveling. What is the
Hmm.
most eco-friendly way? You told that aero, it's
Hmm.
not so good. So what to
Yes,
use?
that's why even large companies reduced number of business trips now, because airlines are not eco-friendly. But also some airlines, they claim that they will use eco-friendly fuel. I don't know how it's possible. It's
Mhm.
interesting. So maybe when you select a plane which flies on eco-friendly fuel, it's better.
Okay, maybe in the future.
Yeah, but
Uh,
better to travel by bicycle.
okay, got it. So, and how can we evaluate our personal carbon footprint? For example,
Mhm.
some applications maybe.
Yes, right. There are a lot of applications. For those who work at EPAM, we have our own application, as far as I know,
Mm.
which may help. And online, just Google. There are a lot of them. There are also sites which may help to evaluate carbon footprint, not personal, but of your cloud solutions as well.
Okay, uh, thank you. Next question. What is more eco-friendly way to transfer data? Via optic fiber cable, metal cable, satellite, or with trucks?
I don't know.
Okay. So next question is more about greenhouse gases. How is greenhouse gases connected with ozone holes?
They affect their growth. And regarding the last question about trucks, I think that if it's a really large amount of data, then probably it will be better to load the data on some device where the data is stored and to bring it by truck.
Okay. Um,
And
so
cheaper as well.
mhm. The next question is quite funny. Based on information that you provided, does it mean that data centers in Matrix movie are very eco-friendly?
The people used as data centers. I don't know, but not for people.
Let's assume that they are really eco-friendly. We hope. Um, so I guess we ran out of questions. So, and let's conclude our session. Thank you all so much for joining us today. We hope you found this session insightful and inspiring. In the video description below, you will find a link to the talk page where you can provide feedback on this talk, give speakers a badge, rate the session, and download this presentation. Thank you very much, Alexandra, for coming. Now we all
Thank you.
know exactly what we can do to help our planet. And once again, thank you all for your participation, engagement, and support. We look forward to seeing you at your next sessions. And until then, stay curious, stay inspired, and keep exploring the exciting world of data. And goodbye for now.
Thank you. Bye.